In this video, we'll be working on differentiating from first principles, which is part of calculus for grade 12. Now, usually how this goes is they will give you an equation that is called f of x or g of x, but the most common name would be f of x. Here we have f of x is negative 4x squared. And we need to differentiate this, so we need to get the derivative by using the process called first principles. Now, before we use a formula for first principles, it is always best if we get f of x plus h. So how we do this is, in our equation, wherever we have x, we replace it with x plus h. So here we had x squared. Notice I've replaced it with x plus h, and the square now goes for x plus h. Now we need to simplify. So in this bracket, we've got a binomial squared, which is going to result in a trinomial. To get the first term, we square the first term. To get the middle term, we multiply both together and we times by 2. That gives you plus 2xh. And to get the third term, you square the second term, so h squared. Now we can take that negative 4 and multiply into the bracket with all three terms, giving us negative 4x squared, negative 8xh, and negative 4h squared. Now that you have f of x plus h, you can now write down your formula for first principles. Remember the way the formula goes, we have f prime x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So the good thing is that this formula is usually given on your formula sheet. So just in case you forget it or you get confused, you can always refer to the back of your exam paper and it will be there. Now, you guys notice that the formula has f of x plus h, which we had already gotten initially. So it's always good for you to get f of x plus h. It saves you a bit of time. It leaves less room for error by getting it beforehand, so you can just substitute into the formula. So we're now going to say the limit as h approaches 0. Substituting f of x plus h, we had negative 4x squared minus 8xh minus 4h squared. Now we have a negative, and notice here we've got this f of x. F of x comes from the question, okay? So it was what was given to you in the question. We had negative 4x squared, so that is what we're going to substitute. Negative 4x squared. And it is always best if you substitute in a bracket, seeing that there is a minus in the equation, which needs to multiply into that bracket. So that is the next step. We are going to get rid of the bracket by multiplying that negative into it. So our first few terms would stay as is, but our last term now becomes, we've got negative times negative 4x squared, that becomes positive 4x squared, and in our denominator we've got h. At this point, you notice that you've got negative 4x squared plus 4x squared. They can cancel out with each other. Now what you notice is that from the terms that are left, you've got negative xh minus 4h squared. These terms have something in common with each other. They both contain h. Let's pull out h as a common factor. In the first term, we're left with negative 8x. In the second term, negative 4h. And don't forget about the h in the denominator. What now happens is the h that you have factored out cancels out with the h from the denominator. And you guys have noticed that in every step, I've always started off by writing down the limit after the equal to. But when do we not write the limit? Once you factorize and the h's cancel out, if there are any terms that still contain h, that is when you make use of the limit. And what do we mean by make use of the limit? It means that we actually substitute 0 in place of h. Now, since you've made use of the limit, you cannot write down equals to and start off with the limit. Remember, you are using up this limit, so it's no longer there. We've taken the 0, we've substituted, and when we simplify, we get negative 8x. Our second term becomes 0, so we don't need to show that. So this is our final answer. Therefore, f prime x is negative 8x, meaning that we have differentiated from first principles, and this is our derivative. So this is the answer. Please remember to like, subscribe, and turn on your notifications for more content.